Okay, welcome ladies. Today for today's lesson, we'll be dealing with only one area, which is types of volcanoes. So we'll be looking at both types of volcanoes in the syllabus, shield volcanoes as well as stratovolcanoes. Note that shield volcanoes in some texts and resources are also referred to as basic lava volcanoes. Stratovolcanoes are also referred to as composite volcanoes. So for today, we will be covering the formation, the cross-section, as well as some of the eruption properties of these two types of volcanoes. You'll be also required to do two drawing activities, as well as at the end of it, we may practice one description question where I will give you a stimulus or a question, recall question, asking you to describe the eruption of one of these volcanoes. So why would there be different types of volcanoes, different shapes and sizes? Basically, it's due to the different type of lava that's present in the area. Now, you may be thinking if we learned earlier on that the mantle material is one continuous blob of molten magma that is in the mantle itself, there shouldn't be a difference between the composition of lava because it is a continuous blob and is intermingling due to convectional currents. So it should be the same material. There should be no difference in terms of viscosity, which is the stickiness of it. So why is it that you do have different types of lava? Okay, this has got to do with where you find these lava. So if you're looking at acid lava, the one here on the left, right, acid lava tends to be very thick, okay, very viscous. So when you pour it out, it flows very, very slowly. The closest I can think of is honey. So if you pour honey out onto the table, it will flow, right? It is still a liquid, so it will flow, but it will not flow very quickly. Okay, its opposite will be basic lava, which is fluid, less viscous, not as thick. So think of basic lava like your water from your water bottle. If you were to accidentally spill some water on your table, it will flow very quickly off the table onto the floor, okay, making a huge mess in the process. Honey will still make a huge mess as well, but it will flow slower. So how do you get enough materials inside the lava to make it flow slower? Okay, because if you're looking at acid lava, one key component here is the third point, high silica content. Now, where is this silica from? I need to bring you back to our earlier diagram of oceanic continental convergence. So when you have the oceanic plate and it subducts downwards, what is happening? The plate itself is not the only thing that's subducting. Right, on top of the oceanic plate layer, you do have the seabed, which is being pulled down into the mantle area. So what is on the seabed? Right, when you go to the beach, generally, what do you step on? You step on sand. The highest component that is found in sand is silica. So there is a large amount of silica that is being added into the lava at the point of subduction in the subduction zone. So this is why the lava in the area is being contaminated with your seabed material. Both the carbonized materials of the material of the dead bioorganisms as well as the sand that's being pulled in. So when you have introduction of these kind of contaminants, the composition of the lava at that point will be different. That's why you find acid lava, and as a result, you find a different type of volcano. Okay, so where is acid lava normally found? It's found where you have subduction. So if you have subduction in the area, there's a high chance of you finding acid lava in the area. Now, of course, in the long run, when you talk about it from a global perspective, it will pan out. It will get mixed due to the convection currents and it will get diluted to the point where if you move slightly further away from the convergence, from the subduction zone, you will actually find that it comes to a point where it dilutes to a point where it becomes the same. Okay, so basic lava is the common type of lava that you find without subduction. So where do you find this? You find this at constructive plate boundaries, also known as divergent plate boundaries, where you find your rift valleys and your block mountains. So because it is fast flowing, what happens is your volcano, the shape that is produced from basic lava tends to be very gentle, okay, but it tends to be able to spread very quickly, so it is very wide at the base. Right? How wide? It can be up to about 80 to 100 kilometers wide. Okay, and that's a lot of distance. For the stratovolcano, you don't have that kind of a wide base normally. You do have very steep sides because it's able to pile up, it's able to grow higher and higher and solidify much faster due to its high viscosity, low ability to flow away quickly. So generally, what do you see? For shield volcanoes, the ones that you see they are formed with basic lava, you tend to have very gentle sides. Okay, very, very gentle sides, layers upon layers of lava and ash material being piled by the side. It flows very quickly, so it flows out very evenly. Very little chance of fracturing occurring in the shield volcano. Your base is very, very wide. Your sloping side is very gentle. So like I mentioned earlier, the base can be over 100 kilometers in diameter. Now, why is it called dome shape? Because if you look at it, it actually looks like Captain America's shield. Okay, you can take a look at the picture here that I'm encircling. I'm trying to circle with my mouse. Okay, this picture here is a dome. Okay, so where do you find them? Once again, you find them near divergent or constructive plate boundaries. Largely, how do they get so wide? Because the lava is able to flow very quickly. It has low silica content. It doesn't trap gases. So when you have eruptions, they are very gentle. Okay, they're like bubbling. It's like when you boil what is very thick. Okay, you boil something that's very thick. Okay, so it just bubbles, bubbles, bubbles. It never has that gigantic boom or boom or explosion. So this is the key thing about shield volcanoes. Now, how do you draw a cross section of shield volcano? These are your key annotations. You need to tell me what are the layers, where do you find the crater, where do you find the pipe, and the vent, which is the opening near the top of the pipe. Okay, where the crater is. Okay, it is the opening on the Earth's surface. Okay, with a pipe leading to the magma chamber. So the top is called the opening itself is called your vent. The top of it, okay, where the rim is called the crater. If it explodes and becomes very much larger, it will be called caldera. Okay, so magma chamber, Earth's crust, these are your general things that you need to put down for cross section of a shield volcano. So at this moment in time, I will give you a short break, okay, of 5 minutes. Please sketch this on a piece of paper. Later on, you need to leave some space because you're sketching the cross section of a stratovolcano below this. So take 5 minutes, sketch the cross section of a shield volcano.